Hello and welcome to a new video. This is for pre-algebra, and in it we are talking about exponent rules. So one of the things that we will be better off in Algebra 1 if we know is how to work with exponents whenever we've got x's. So the basic idea is going to boil down to a couple of things. If you have x squared times x cubed, what that's telling you is that you have x times x times x times x times x, because x squared is x times x, x cubed is x times x times x. So in reality, we could write this shorter by saying there's 5 x's being multiplied together, so this could be rewritten as x to the 5th. And what's neat about that is 2 plus 3 is 5, and if you kind of think through like how we came up with 5, it was because we took the 2 x's and the 3 x's, we added together how many x's there were and got 5. Another big concept then is whenever we have fractions, how this works. So if I have x to the 5th over x squared, that would be like having x times x times x times x times x over x times x. And so what we can do is something similar to what we maybe did whenever we were learning about fractions and simplifying fractions, is if you have the same thing on top and bottom and all of this is multiplication, then we can actually cross out what's in common. So the fact that I have 2 x's in common on top and bottom means I can cancel out 2 x's from the top and 2 x's from the bottom. And so that means this simplifies to be x to the 3rd power. And if I look back at what I started with, the x to the 5th over x squared, well, 5 minus 2 is 3. And if we think about how we got from 5 x's on top, 2 x's on bottom, to now we have 3, like, that makes sense. We're canceling, so we're like kind of subtracting what they have in common. The other thing to talk about is negative exponents and what happens when we have an exponent of 0. So I'm gonna fill in over here some things. We're gonna talk about and like kind of expand our idea of some exponents here. And this may be something that you've seen before in some form or fashion. Maybe not, but I'm going to do my best here to get us all on the same page. So I kind of want to just pick out from here, like, what is the easiest of these to find? And I actually think that probably 10 squared is the easiest, because 10 squared is 10 times 10, which is 100. 10 to the 3rd power would be 10 times 10 times 10. So we'd take 100 and we'd times it by 10 again and get 1,000. Then 10 to the 1st, that may have been the one that you thought was easiest, and it really just depends on if you remember what the 1st power does. So saying 10 to the 1st means I just have 10. That's all I have. And then if you haven't talked about 10 to the 0 and 10 to negative exponents before, this will be new. We want to come up with like what makes sense to go here, because math is like all patterns. Nothing in math just kind of seems to randomly happen. Well, maybe nothing is too strong a word there. Like, things typically happen in a way that we could predict if we really tried. So the way I'm going to predict what 10 to 0 is I'm going to look at this pattern of how do I go from 1,000 to 100? How do I go from 100 to 10? It's the opposite of if we went the other way, because the other way it's easier to think of. How do I get from 10 to 100? I'd have to times by 10. And how do I get from 100 to 1,000? I have to times by 10. So to go the other direction, what we're doing is we're dividing by 10. So think about that. 1,000 divided by 10 gives us 100. 100 divided by 10 gives us 10. So then what happens when we do 10 divided by 10? What's that going to give us? That's going to give us 1. So 10 to the 0 power is 1. But it just so happens that anything to the 0 power is 1. So 5 to the 0 power is 1. 27 to the 0 power is 1. 1,000,000 to the 0 power is 1. X to the 0 power is 1. Everything to the 0 power is 1. Perhaps with the exception of 0 to the 0 power, which is not a situation that should come up, because that's just, well, yeah, that's a weird thing to have. You shouldn't end up being asked that. But my best answer for you would be that that would be an undefined value. Kind of like when we divide by 0. Anyway, let's keep going. What happens when you do 1 divided by 10? There's actually 2 ways to write this. You could write it as a fraction or a decimal. I'm going to write it as a fraction because I want to point out more of a pattern here. So 10 to the negative first is actually 1 over 10 if we keep going with this pattern. If I do 1/10 divided by 10, then I'd actually end up timesing by 1 over 10 because when we divide with fractions, we have to flip the second fraction. So 10 to the negative 2 ends up being 1 over 100. And then we keep going. 10 to the negative third should be 1 over 1,000. And if you're like, I just don't believe you, you can actually type into a calculator, depending on what kind of calculator you have, you can type in 10 to the negative third. It should tell you that it's 0.001, which is the decimal equivalent to 1 over 1,000. So what I want to point out here to you real quick is notice how 10 to the first equals 10 and 10 to the negative first equals 1 over 10. Look at how 10 to the second equals 100 and 10 to the negative second equals 1 over 100. Notice how 10 to the third over 100 equals 10 to the third equals 1,000 and 10 to the negative third equals 1 over 1,000. So basically, negative exponents end up talking about fractions or reciprocals of what their positive version is. So in general, if you end up with x to the negative 5, for instance, we could say that that's the same as 1 over x to the positive 5. Now, just like how we like positive numbers better than negative numbers in general, one of the things we'll do as we're working out problems is we'll actually say, I don't want negative exponents in my answer. And that lets us all get the same answer more easily. And then it's kind of like mathematical politeness. It's more polite to have positive exponents than to leave it with negative exponents. So we're going to do some of these examples together here. But that was all background information that you may or may not have known about. And now I'm going to look at this and go, okay, I'm being told to simplify. That means my answer should take less writing than what I started with. And so what do I do if I have this 7x to the fourth times 7x squared times 2x? How do I make this simpler? Well, there's kind of 2 things we can do here. Since this is all multiplication, we can actually rearrange it so that we're multiplying the numbers together, the regular numbers together, and then multiplying the x's together. And so that means we can do 7 times 7 times 2, which is 49 times 2, which is 98. And then we can say, well, x to the fourth, x squared, and x. That's having 4 x's plus 2 x's plus another x for the x that doesn't have an exponent. So in total, that's 8 x's that are being multiplied together. So this ends up being x to the 8th. If you're not able to figure that out the way I just said it, write out x to the fourth as 4 x's, and then x squared as 2 x's, and then x as a single x. And then count how many x's do you have. I don't know why I put 8 there when that's supposed to be 7. I somehow screwed up counting earlier. Sorry about that. That's x to the 7th. It happens to the best of us. It's a good thing that I checked by writing it out. This should be 98x to the 7th. I'm really sorry if I threw you off by saying it was x to the 8th. So now you try number 2, if you'd like to. Let's look but I'm going to look at 3 together with you. So I, in class, went over odds on this page and then had my students do the even ones on their own. So in this case, we do, 2 times 7 is 14. P cubed and p to the fourth together make p to the 7th. So that'd be our answer. Let's look at this next one. 5k squared, and then we've got another squared. So when we square something, that means, hey, take what you have and multiply it times itself. So what would we get if we did 5k squared times 5k squared? How do we approach that? Well, we can, if we rewrite it like that, then we can basically approach it the same way that we did 1 and 3. That I can say 5 times 5 and get 25, and I can say k squared and k squared together make k to the fourth. So that would be my answer. Let's look at 7. TR cubed to the second power. So that'd be like having 2, I think I said T, 2R cubed times 2R cubed, which is 2 times 2 is 4. R cubed and R cubed together, that's 3 R's in each, so that makes a total of 6 R's. So that's 4R to the 6th power. So just remember, whenever it asks you to square something, or put it to the 3rd power, like on 8, it's telling you how many times to write it down, and then we multiply it together. 9 and 11 here. I actually need to do, I'm going to do 9, 10, and 11 on this one to make sure that we've got an idea of how to do this. So on 9, we've got a fraction. We've got 5 over 5. So we're going to kind of do this as 2 separate things. 5 over 5 we can simplify, and that gives us 1. And then k to the 4th over k to the 4th we can also simplify by saying how many k's do they both have. So k to the 4th over k to the 4th, those are the same number of k's, so they actually just cancel out completely. This ends up being 1 because we have the same thing on top and bottom. That's the only way we can get 1, is by having the same thing on the top and bottom, or by having something to a 0 exponent would give us 1. 4b over 6b to the 4th. We're going to simplify the 4 and the 6. So we're going to say, okay, they both have a 2 I can divide by, so this is going to have a 2 on top and a 3 on bottom. Then we look at the b's, and my personal preference for how to do this is to think, I have more b's on the bottom, so a b is going to cancel out, but then these 3 b's that are left will still be on the bottom. They'll still be on the bottom. So this would be our answer, 2 over 3b cubed. And it's somewhere around this point that I normally think, I bet this seems like a really weird thing that we're doing. We're practicing a skill that we're going to get better and better at as we grow up in math and just like go through algebra and stuff. And it's a little bit hard for me to explain to you why this is relevant to the real world, because we're really just trying to practice a skill here of how does simplifying with variables work. And it's a skill that you will use later on in your math classes, and you may use later on, I guess, if you use math in real life. But right now, it's just, this is what we're doing. We're practicing simplifying these things. It's kind of weird, but that's what we're doing. And so, like 11, 8 over 3 does not simplify. We don't need to change it to a mixed number. Once you get to algebra, you stop changing things to mixed numbers unless you really have a good reason to change it. And then we do x squared over x, which would simplify to just be an x on top. So 8x over 3 would be our answer here. Here on 13, we have a negative exponent. This is where it's like, is this really simpler if I rewrite it with positive exponents? And I would say, maybe not. But we like it better with negative exponents. So the important thing to note here is that this negative 4 exponent does not affect the 3. If they wanted this 3 to be affected by it, they would have had to write 3x in parentheses to the negative 4th. And that's not what they wrote. So because they didn't write that, we need to think about 3's exponent, which is 1, and is positive. So 3 doesn't need to move down to the bottom. If we did move it down to the bottom, we would need to give it a negative exponent, and that's not helpful. So 3 is going to stay on top of our fraction, but in order to make x have a positive exponent, we're going to put it on the bottom. So that this simplifies to be, or the best answer here is 3 over x to the 4th. So for 15, 5 gets to stay where it is because it's 5 to the 1st. Y squared gets to stay where it is, but we're going to move the x down to the bottom to give it a positive exponent. So this is going to be 5y squared over x squared. And that's our answer. For 17, we could do 5 times 6 and get 30. And then we could do this next part in a couple different ways. I would add the exponents together and get x to the 0, which means that's just 1. So 30 times 1 is 30. You also, though, could go ahead and move this down to the bottom and then you'd see the x squareds cancel out. That's one of the other reasons why x to the 0 ends up being 1, because if you have x squared over x squared, those cancel out and become 1, and 2 minus 2 is 0. So there's that connection as well. Like I said, this is a skill we're practicing that we'll build on as we go through Algebra 1. At least some of this is helpful for some upcoming lessons where we're talking about polynomials and how to work with them. So that's why I wanted to put it where I did. Thanks so much for watching. Hope you enjoyed the video, and I'll see you in the next one. Bye.